Hi, I'm Archimedes of Syracuse, the famous mathematician and inventor in ancient Greece. I was born in 287 before Christ at Syracuse, Italy, and died at the age of 76 years old. I was also known as the father of mathematics. My father is an astronomer named Phidias, and my family was related to the King Hiros family. Hyro and I are good friends. I discovered the relation between the surface and volume of the sphere and its circumscribing cylinder. My discovery is especially important now. I am also known for my formulation of hydrostatic principle known as the Archimedes principle and a device raising water still used developing countries now and that they called Archimedes screw. My teacher at the time is the student of Euclid, who was another Greek mathematician. My greatest achievement in life and in mathematics. First, Archimedes' principle. Archimedes' principle helped us to understand why something floats or sinks in water by showing that the amount of liquid displaced is the measure of the sinking or rising capability of the object. The weight of the displaced liquid tells us if the object will float or sink. Second, the sand reckoner. The sand reckoner is a work of mine in which I attempt to count the number of grains of sand. First, I had to work out on how to count a number with a large base. And I established a new theory in mathematics which could count a number to an infinite value. 3. Evaluation of pi. I used the Hellenistic method of mathematics. Pi is a Greek symbol which is used in various formula, and I was able to derive the value of pi using my exceptional intellect. Pi is a numerical value approximately 3.14, which is calculated by dividing 22 by 7. Fourth, the claw of Archimedes. To protect my city of Syracuse, I designed a hook that could latch onto an enemy ship and sink it. This was known as the claw of Archimedes, or the iron hand. Fifth, Archimedes screw. Archimedes screw was more of a pump than a screw. It was used to pump water against gravity. The screw could be turned using any physical means such as manually or by wind using a windmill, and it was essential in helping farmers to irrigate their lands. 6. Archimedes' death ray. This parabolic mirror structure was used to concentrate sunlight over a particular area on a ship, which will then catch fire. The concept was again developed as defensive mechanism for my city of Syracuse. By catching fire to enemy ships, we were able to defeat the faceless Roman army. 7. The odometer. An odometer is a device to measure distance covered. The word odometer comes from the Greek word hodo, which means way or road. 8. Archimedes catapults. The catapult was a system of propelling heavy stones or objects at enemy ships to destroy them. This kind of machine usually had a bucket in which the projectile was kept and the missile was fired from the catapult manually. 9. The law of the lever. This weighing machine worked on the principle of equilibrium, which can be achieved using the lever. The lever works on the principle of the center of mass. 10. Discovery of infinitesimals. Infinitesimals in the ancient Greek period were the equivalent of modern-day calculus. An infinitesimal is a quantity which does not exist but can be made real using limits. 11. Shapes and their design. Many years ago, people used to measure time using stars and the moon. And from that time onwards, people have to differentiate between different shapes and structure. At that time, people don't know about 2D and 3D shapes. They only knew of lines, circles, cubes, spheres, pentagons, etc. That was when I started thinking of parabolas, eclipse, and hyperbolas. I introduced the idea of projectile motion with the help of the parabola. Last, the formula for surface area and the area of a sphere. A sphere is a 3D circle which is comprises of 4 circles laid together, edge to edge. Calculating its surface area as well as its volume was not an easy task, but I was able to calculate the surface area as well as the volume of the sphere by first calculating the surface area of the sphere using 6 pi r2 and the volume is 2 pi r3. Hi, I'm Archimedes. Now, I'm going to give you an example of Archimedes' principle, the buoyant force. Example, a block of wood with length of 2.5 meter, width 0.5 meter, and height 0.4 meter. The density of water is 1,000 kg per cubic meter. If the block is placed in the water, what is the buoyant force? Acceleration due to gravity is 10 net per kilogram. A buoyant force is the next upward in any object in any fluid. The buoyant force formula. F is equal to P times G times V. F is the buoyant force, P is the density of water, G is the acceleration due to gravity, and V is the volume. And this is the given. Volume is equal to length times width times height is equal to 2.5 times 0.5 times 0.4 is equal to 0.5 cubic meter. And the density of water is 1,000 kg per cubic meter. And the acceleration due to gravity is 10 net per kilogram. And now we're looking for the magnitude of the buoyant force. And we are going to use the formula of F is equal to P times G times V. Solution. The formula P times G times V. Our P is 1,000 times our G is 10,000 times 0.5. First, 1,000 times 10 is equal to 10,000 times 0.5. And now we have 5,000. And this 5,000 is the magnitude of the body. Archimedes was a person of great importance as well as being a renowned mathematician, inventor, scientist, and a philosopher. He was also a true patriot. Archimedes is an example of the classical as well as the Hellenistic period of ancient Greece. He died protecting his city of Syracuse from the Romans using mathematical calculations and his experiments. Great philosophers lead to great philosophies, and the inventions of Archimedes have an enormous impact on our daily lives and made them much easier. Give me a place to stand, and I will move the world.